Hello, math humans. We're going to do D4 today. We're going to be solving radical equations by graphing. Our objectives are that we're going to solve radical equations by graphing. So if we review what we have done before, because we have solved equations by graphing before, the only thing that's changed this time is now it's a radical equation. So here were our basic steps. So we would turn the equation into two equations, righty? So we would do y1 is equal and y2 is equal, and then we would put those in our grapher. So we would put the two equations in our grapher, and since I'm graphing two equations, the solution is the point of intersection between the two lines. And they could be curves, but we're going to call them lines for right now. Okay, so, and then we find, whoops, that's supposed to be a D. Oh, we'll just redo that. Find the point of intersection. And we're going to do that using our grapher. Okay, and to do that, it's going to be second, and then calculate, and then we're going to choose intersect, and then we just have to get close to that point of intersection, not exactly there, but just close, and then we're going to do enter and then enter. Okay, so let's do our first example. We only have two examples today, lucky dogs, because we've done this before, so we're going to have a nice short day. First example says solve by graphing. Yay, we like to solve by graphing. So the equation that you're going to be given is the third root of 7 minus 3x is equal to 4. And so then I'm going to turn this into two equations. y1 is going to be 7 minus 3x, and I'm going to rewrite it as 7 minus 3x to the 1/3. This is going to be the second equation, which is a horizontal line. I'm going to put those two equations in my y equals. So I'm going to do 7 minus 3x, and I'm going to raise it to the 1 divided by 3. And then my second equation is the horizontal line. Okay. Now I'm going to do a zoom 6. So there goes my first equation. And then there's my second equation. So this presents an interesting situation. The point of intersection is probably over here somewhere, and I can't find that on my grapher unless my grapher can see it. So I'm going to do zoom 3 enter, and it's going to zoom out a little bit on my graph. So it's going to redraw it, and the point of intersection is probably right here, and it's okay if I can't see it really well. So I'm going to do second calculate 5 for intersect. Right now, my calculator is on the first equation that I entered. I'm going to use the down arrow and get to the straight line, because the shortest distance between 2 points is a straight line. I'm going to get close to it, enter, 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 and my calculator pops right to that point of intersection, and it tells me that the xy is going to be a negative 19 and 4. So this is the solution. Remember that if we use our calculator, we have to sketch the graph. So I'm going to sketch my graph. So here's my, here's the equation. And then here was my horizontal line. That was at 4. This was y1. And then that point was a negative 19, 4. Okay, so we always want to sketch the graph if the graph is part of our work, okay? And then this is my solution, and this would be what I would write in the answer column on the test, because this is the solution to the problem, that point of intersection. All right, I have one more example for us, and then we are done for the day. So example number 2, same direction, says solve by graphing. This time I'm going to have the fifth root of 2x plus 10 minus 1 is 0. So what I'd like to do before I start is take this 1 to the other side. So I'm going to rewrite my equation, 2x plus 10 is equal to 1. Because remember, when you cross that equal sign with adding or subtracting, it changes signs. So yes, I could show that I added 1 to both sides of the equation. Either is fine, whatever makes your brain happy. Now I'm going to rewrite this equation as 2x plus 10 raised to the 1/5 is equal to 1. I'm going to graph y1 as my 2x plus 10 to the 1/5, and my y2 is going to be 1. So I'm going to put those two equations in my handy-dandy grapher. So I'm going to clear what's there. So I'm going to enter 2x plus 10 raised to the 1 divided by 5, and then there's my 1. And I'm going to do a zoom 6. I had changed my zoom window for the last graph, so I always go back and put in zoom 6. Alrighty. No extra zooming required on this one. There's my point of intersection right there. So second, calculate 5 for intersect. Again, I'm going to use the down arrow so I can trace the straight line, because the shortest distance between 2 points is a straight line. Enter, enter, enter. And that point of intersection is a negative 4.5, comma 1. So I'm going to record my answer. X, comma, y is a negative 4.5, comma 1. And then I have to sketch the graph, because the graph was my work. It crossed at over here, and then here was my point of intersection. So that point is a negative 4.5, comma 1. When you're graphing two equations to find the point of intersection, all you really have to do is show the graph and label that one point of intersection. I don't need to label my y-intercepts or my x-intercepts, because this is the only point that's relevant. Alrighty, that is it for today. I will see you soon.